So here is one possible way that the AP people can test your knowledge of integration without really allowing you to look it up, say on Wolfram Alpha. Here we're going to determine an equivalent integral to this integral I made up. Now they probably won't have this exact specific type of question, but it's just something to keep in mind. So if we want to find an equivalent integral to this, you can notice up top is a composite function. So usually what you do is you pick a good u-substitution for what's usually in the inside. And what's in the inside of this function is the square root of x. And as we are trained to do, you think about what du is going to be. And that's going to be 1/2 x to the negative 1/2. And if you look at the bottom of that integral, that's what we need. So that looks like a good substitution in this case. Du is 1/2 x to the negative 1/2 dx, or 1/2 root of x dx, which means 1/root of x dx is 2 times du. That's this part of it. So my u-substitution was u is the root of x, so now we have f of u. The dx over x, according to our du, is dx over root of x is 2 du. So this circle arc can be substituted with 2 du, and there is an equivalent integral. Now the only other thing is, if this were a definite integral, which we're not really working on now, but say it was a definite integral from 2 to 8. Now you'd also have to change those limits based off your u-substitution. So our new limits would have been root 2, because that was an x. When you plug it in for x, now it's a u. And then the new upper limit would be root 8. So that's the type of example I was talking about.